Okay, today we're starting up the condensate system. The plant's just come out of an outage. We've had our plant equipment operators out checking the equipment, making sure the condensate pump breakers are racked in. The motor breakers are closed, drains are closed, and all maintenance work has been completed and everything is sealed up. First thing I want to do is make sure our level control valve is in auto. This will add water to the surface condenser from the condensate storage tank. This is demineralized water. It has to be very pure water in this system. We have our trend up here. We look at the condensate pump motor amps. Motor temperature will be the stator temperature on here. Discharge pressure and condensate flow. This is a 1,000 horsepower motor, runs 7,200 volts. So we need to pay attention to the amps, how long it's pulling full current, and the temperature. Once again, we're going to enunciate that we're starting the pump just for personnel safety. Attention all plant personnel, starting A alpha condensate pump, starting A alpha condensate pump. Just let everybody be aware. Okay, we're going to start the pump. We'll have an operator standing by the pump to verify that it starts well. You should have somebody always watch motors when they start or equipment. Keep everybody away from the starting piece of equipment and in case something's going wrong. The condensate pump has an arc valve. It's a combination check valve and automatic recirculation valve. It maintains minimum flow through the pump back to the surface condenser. As you can see, the discharge valve is full closed when the pump starts and slowly opens. This prevents water hammering the system and allows the motor to start under not full load conditions. We're still pulling quite a bit of current and the pressure is still coming up, so we're filling up the line. Next, this plant has polishers. They're resin beds. They remove cations and anions out of the water. Have to have very pure water. These play a big factor. If you have tube leaks in the surface condenser, they'll clean up the water and also removes any rust or particulate in the water. Also, that kind of looks like a filter. They're bypassed right now because we have in our water treatment chemical. We've used hydrazine. It's been added as an oxygen scavenger to prevent corrosion. All our feed water heaters are bypassed. They have copper tubes in them, and we don't want to hit them with the water treatment chemical, and also don't want to water hammer them during startup. Here we have our Gland steam condenser. This condensing the Gland steam out of the turbines. We put steam to the low pressure turbine. Part goes into the turbine past the seal to keep air out, and the other part will come out to the outside. This keeps steam from getting into the bearings and filling the room full of steam. It's also on the high pressure side too. It just keeps steam from getting in the bearings and filling the room on both ends of the turbine. It goes down to a condenser. Then there's a Gland vacuum pump that keeps slight negative pressure on this just to keep a slight flow of steam and air through here. This adds about 1 degree to the feed water. It looks like our motor amps are starting to drop a little bit, so we're full. There's a recirc valve going back to the surface condenser. When your deaerator control valves are closed, it maintains a minimum flow through the Gland steam condenser. This is pretty common. A lot of plants, you have to maintain flow through your Gland steam condenser because anytime you have steam on your turbine, you're going to have Gland steam to condense. And your control valves can go closed occasionally on the deaerator. We're going to open the deaerator valve. Right now it's in manual. You don't want this in auto because it would slam the system. We're going to slowly open it. Like I say, all the feed water heaters are bypassed so we don't damage tubes. The feed water heaters really won't come into play until we hit about 180 megawatts, as they're on the low pressure turbine. It'll take a few minutes for the system to fill. Okay, the feed water heaters, both ones, 1A and 1B, come off at stage 20 on the low pressure turbines. There's two low pressure turbines. One is A, which feeds condenser A, and the other one is B, which feeds condenser B. So we have one IP turbine. The exhaust from that feeds two low pressure turbines. So these two come off at stage 20 off the low pressure turbine. Feed water heater 2 comes off a B low pressure turbine stage 19. Feed water heater 3 comes off stage 18 on steam turbine A. The reason the difference, we're trying to reclaim all the heat we can to reheat feed water. The steam feeding these, we're recovering a lot of the entropy heat, which is the phase change from water to steam. It's about 1100 BTUs or so. That will just be wasted. It'll be condensed in the condenser and rejected. So we've expanded the steam and took a lot of the heat energy out of the steam has been extracted, so we can recover the rest of that energy and reheat the feed water. So this really increases the plant efficiency. Feed water heater 2 is coming off of stage 19, which is warmer steam than 1. And 3 is warmer than 2, so the steam has to be extracted as it expands. Your last stage of the turbine would have to be too large to deal with it. So we expand the steam through most of the turbine, then recover the energy instead of wasting it in the condenser, reheat the feed water. So this helps improve the plant efficiency. As you can see, now we got flow going to the deaerator. We're going to start opening up the deaerator drain valve just a little bit here in a minute. We start getting some level in here. We want to recirculate the water through this system to the deaerator and back to the surface condenser. Next thing, we're going to start pegging the deaerator, which is using steam to heat up the water and remove oxygen. We're going to put a vacuum pump in service and start pulling vacuum on the condenser, which will remove more oxygen. Then we'll start a polisher and start cleaning up this water. We want this water about 220 degrees when we start filling the boiler. It's going to take about 150,000 gallons of water to fill the boiler. We'll add more water, more chemicals to the boiler when we start filling it. The big thing we want to be careful of is have very clean water. You don't want sodium and chlorides. They will cause cracking on turbine blading. Silica will cause a glass to form on the turbine blades and reduce efficiency. You also have organics in the water. You don't want any hardness minerals like calcium and magnesium and bicarbonates. The deaerator will strip out any oxygen and carbon dioxide out of the water and any volatile gases. Out of the surface condenser, we look at cat conductivity. This will tell us we have a tube leak. This many tubes in these condensers, and they get older, you will have tube leaks. So your polishers are kind of the first line of defense. These will clean up the water. And you notice your polisher is going out quicker. You know, you get a tube leak, you can tell about how bad it is, how fast your polishers go out. But you're also checking pH, cat conductivity, dissolved oxygen, other parameters.